In the last lecture, we have studied the Maxwell's first equation, that is divergence of d bar is equals to say rho. Second equation, divergence of b bar is equals to 0. And today we are going to study the third equation, divergence of b bar is equals to minus dou b bar by dou t. And the fourth equation we have already studied in the displacement current, divergence of h bar. Divergence of h bar is equals to what we have to consider, that is j plus dou d bar by dou t. These four equations we have considered here, and from that four equation, first one is what, divergence of d bar is equals to rho, that is we have proved. Second one is divergence of b bar is equals to 0. Third one is curl of b bar is equals to minus dou b bar by dou t. And fourth equation also we have proved, that is what, curl of h bar is equals to j bar plus dou d bar by dou t. This equation we have already proved in the displacement current. So remaining only one equation, that is what, third equation, and in this way this chapter can be finished in the today's lecture, that is curl of E is equals to minus dou b bar by dou t. How this equation can be proved? This equation can be proved by using the Faraday's law of electromagnetic induction. We know the Faraday's law of electromagnetic induction. Whenever there is change in current whenever there is change in flux, what will happen, that the EMF is induced in the circuit. That is the first law. And secondly, in second law is what, induced EMF is directly proportional to rate of change of magnetic flux. That is by Faraday's second law. By Faraday's second law of electromagnetic induction, what we have to say, that is E is equals to minus d phi by dt, that is called as Lenz's law. Here we have to say that E is equals to d phi by dt. Faraday's second law is what we have to say, that E is equals to d phi by dt, minus of d phi by dt, that is what we have to say, that by using Lenz's law, negative sign indicates that direction is what, opposite. But phi is equals to what, d phi is equals to b bar dot ds bar. B bar dot ds bar. D phi is the magnetic flux. Magnetic flux is the product of a magnetic induction into the surface area. That is d phi is equals to b bar dot ds bar. And then we have to get that integrating Kelita Gavin. Therefore, integration of phi is equals to integration of d phi, and that is equals to integration over the surface S b bar dot ds bar. This is the magnetic flux. Put in equation number say 1. Equation 1, what we have to get, that E is equals to, we have sign is what, negative, and that is dou by dou t into what, surface integration of b bar dot ds bar, and integration is dou by dou t is taken inside. What we have to get, that is negative sign is there, integration of over the surface S dou b bar by dou t into ds bar. This is the equation, what we have to say, that equation number 2, that is E is equals to surface integration of dou b bar by dou t, where we have to consider b bar is the magnetic induction and ds bar is the surface area. Since surface area S is having any loop of the boundary, EMF E can also be found calculating the work done in EMF E can also be found. EMF E can also be found calculating work done in carrying a unit charge completely around the loop. Work done carrying unit charge, that is E is equals to, E is what, EMF. EMF is considered as a electromotive force, that is over a closed loop is considered as a C E bar dot dl bar. This is equation number say 2. In equation number 1, what we have to say that E is equals to minus of surface integration of dou B bar by dou T into ds. And in equation second, the EMF can be also found by the work done carrying unit charge over a closed loop. That is E is equals to E bar dot dl bar. From equation 1 and 2, what will happen that in the left hand side there is induced EMF, that is electromagnetic EMF, and from that we have to say that line integration of E bar dot dl bar over the closed loop C is equals to minus of surface integration of dou B bar by dou T into ds bar. This is the surface area, and here transform line integral to surface integral by Stokes theorem. Stokes theorem. What is Stokes theorem we have? That is line integration of E bar dot dl bar is equals to, this is equation number say 3. Transform this line integral into the surface integral, that is equals to surface integration of over the surface S, that is curl of E bar into say ds. This is equation number say 4. From equation 3 and 4, we have to see that left hand sides are similar, equating 3 and 4. From equation 3 and 4, we say that, what is equation number 3? Right hand, this is the 4 equation we have, that is surface integration of curl of E bar into ds is equals to minus of surface integration of divergence of B bar divided by dou T into ds. Now both sides we have a surface integration. Surface integration can be vanished. Surface integration can be vanished. What will remember now? Therefore, remaining is here curl of E bar is equals to minus dou B bar by dou T. Hence true. And this equation is called as a Maxwell's third equation, that is curl of E bar is equals to minus dou B bar by dou T. Very simple equation we have to prove here, that is curl of E is equals to minus dou B bar by dou T. By using the Faraday's second law of electromagnetic induction, that is induced EMF is directly proportional to rate of change of magnetic flux, we have to say that E is equals to minus d phi by dt, negative sign by using Lenz's law, that is negative sign is there, E and phi is the oppositely directed, so E is equals to minus dou phi by dt. And we know that by definition of magnetic flux, phi is the product of B bar dot dA bar or ds bar. B bar is the magnetic induction and ds bar is the displacement, or ds bar is called as a area. And here integrating this, what we have to get, that integration of d phi is considered as a phi, and that is integration of over a surface S, because here surface area we have considered B bar dot ds bar. Put in equation number 1, that is E is equals to minus dou by dou T. Substitute the value of phi, that is surface integration of B bar dot ds bar. Operator taken inside, that is minus sign is there. Surface integration of dou B bar by dou T into ds bar. This is the equation number say 2. But we know that electromotive force can be also be calculated or found by carrying a unit charge over the closed loop, that is E is equals to line integration of E bar dot dl bar. From equation 1 and 2, what we have to say that left hand sides are similar, then we have to get that that is E bar dot dl bar is equals to surface integration of minus dou b bar by dou t into ds, equation 3. Transforming this line integral into surface integral. Which theorem is used? For transforming line integration into the surface integration, we have to consider the Stokes theorem, and from 3 and 4 this gets equation number, and surface integral can be vanished with the surface integration. Finally it gets that curl of E is equals to minus dou b bar by dou t, and hence prove this equation. This is called as a Maxwell's third equation. And the last equation, we know that curl of H bar is equals to J bar plus dou d bar by dou t. This equation we have already proved in the displacement current. In this way, the chapter is finished here. Thank you. Write down all the things.